Hey guys, today we're going to be talking about heat transfer and the different kinds of heat transfer. You're going to be doing this in grade 9 in quite a bit of detail. Well, there are three types of air transfer. There is conduction, conduction, which is heat transfer through touch. There's convection, and there's radiation. Let's talk about conduction first. So conduction is the one we are most familiar with. It's through direct contact. So I think we have all burned ourselves while touching, I don't know, plates or hot pieces of pans, etc. So when a metal cooker, let's say, when mainly metals, because conduction relies on the conductivity of a certain element. So if example, if this was plastic and it was under a flame, let's just say if it doesn't melt right now, if you touch the very top of it won't really affect you, because plastic does not conduct heat very well. And you can see that in another one of my chemistry videos. So here we have fire, and this is metal. So if you touch the edge, you'll get burnt, and this is conduction, because metal is conducting a lot of heat. And heat transfer through conduction means if you place another metal, or uh, if you place another metal right over here, this one will get hot as well, because it's touching this, and the heat will transfer to this new metal or new element. Next we have convection, which you wouldn't have heard about, but we all know that hot air rises. And what convection does is, we can use the same example of this. Let's say there is water. Let's say there is water in here, and we want the water to get heated. So what happens is, we know that hot water and hot air rises. And by the way, convection can only happen in air and water. Because what convection is, it's transfer of heat through molecules, air and water. And since the molecules in a solid cannot move, it can only occur in air and water. So on the top there is cold. There's the cold. There's the cold water, and at the bottom there's the warm water. And this is because uh, the the hot water always rises. So, but the flame is at the bottom, so the hot water rises and the cold water goes down. And when the cold water goes down, it gets heated up and rises again, and this cycle repeats itself. So this is a really efficient way of doing things. So another example of convection might be having a heater in your room. Like if you see, even in our school, or even in any school, or in your homes, you have the radiator or the heater um, below somewhere. So um, you have it down somewhere. You don't have it uh, up on the wall, but you have it below the window or something. So it's always down rather than above something, because hot air hot air is usually up. So when cold air is down. So when cold air comes to it, by the way, this is heater. Come on. Anyway, so when cold air comes to the heater, and the heater is below, so the cold air is also below. When cold air comes, it gets heated up. And when the cold air gets heated up, it goes up. And by the way, these are just, you can't really see air, but I'm just representing them. The hot air, the hot air goes up. and when the hot air cools down, it's kind of like the boiling water example. So when hot air goes up, it'll come back down as cold air, and this cycle repeats itself. And this is really efficient, as if the heater was above, the air below would not be getting any heating, and so practically your feet will be very cold, but your face would be warm, which doesn't make sense. And this is also why firemen or people say that when there's fire in your house, always crawl to the door, and this is because all the hot air and the steam will be up, and below will be the coldest you can get. Now we get to radiation, which is also different. Radiation can only occur when there's a vacuum in space. So it cannot occur in water, in gas, even in least dense gas it cannot occur because it needs vacuum. And the classic example is the sun's heat reaching us. During the summer, we feel very warm, and this is the sun's heat. And the sun's heat, let me draw it with yellow. We can say this is the sun. The sun's heat travels to the earth. Travels to the earth. And this is the earth. Earth, and this is the sun. And here there's vacuum. Between the sun and the earth there is vacuum. There's nothing in here. So the heat goes to the earth, and light also goes to earth. So that's what radiation is. It radiates heat. Yeah, and that's what heat transfer means. Now I'll be giving you a few examples of heat transfer. For example, something like wearing two, and oh yeah, another very important part is air. The air around us is not a good conductor of heat. It does not conduct heat very well. It will eventually conduct heat, but it does not conduct heat very well. So anyways, let's say they say that two thin blankets, keep you warmer than one thick blanket. So two thin blankets keep you warmer than one thick blanket. So this is the thick blanket, and this is the thin blanket, and this is I'll let you guess, but I'll wait for some time. Got it yet? Nope. Let me tell you. There's air inside here. There are air, you could say, bubbles inside over here. So when you're under the blanket, and air, as I said before, is not a good conductor of heat. So it does not absorb your heat as well, or it doesn't get influenced by the coldness outside, and it keeps you warm because it doesn't absorb your body heat, and it doesn't let air let the heat escape because it's not a good conductor of heat. And now if you have a thick blanket, it's much worse, because whatever the material is made out of, it might be absorbing heat, or it might let colder air pass through, and colder air will not pass through here because it has air, which is not a good conductor of heat. So yeah, that's one of the reasons. Another thing, another issue is in your fridge, in your refrigerator. The racks are usually like this. They practically have slits in them, and you place the food on the slits. Now, what might be the disadvantage uh, of covering these slits with food? Like, there's no air gap left. So if you just cover the whole thing with a with a big massive pizza box, let's say, the air gap is not there. Well, this causes a bit of inconvenience for the fridge, and you get higher cost that way because air is not allowed to pass through. So in a in a refrigerator, all these stacks are slits, and this is because air can then pass through. Like, the hotter air can go up and get heated by heated by the freezer, because most refrigerators, I mean cooled by the freezer, and most refrigerators have the freezers on top. So cold air can go on top, and otherwise the if you have this whole thing covered by a pizza box like in here, the hot air, all the hot air that wants to rise up will get stuck down here. Will get this will be all hot, and then the fridge will have to go through more it'll need more time and more electricity to turn this hot air into cold air. Whilst if you had air gaps, the hot air will go up and eventually get cooled by the freezer, which will be much faster than getting cooled by a refrigerator. It'll get cooled by the freezer and then go back down again, and that won't happen with this. So these are some everyday examples that you get, and make sure you know how to recognize each one of these: radiation, conduction, and convection. You need to know which one is which. So if you have, this is like, for example, conduction, because air is not a good conductor of heat. This is obviously radiation. This is convection. And yeah, so you need to make sure you know all of these and you know how to identify these. And that's it for heat transfer, guys.